video on motors and generators. Now you might be aware that motors and generators are very similar things. They look very similar, and actually they have a lot of operational sort of principles which are very common. However, they do very different things. So we're just going to race through their structure, their purpose, and then summarize by putting a little slide up just to sort of list those similarities and differences so that you're clear. Let's start with the motor. You can see it here. It's made of a magnetic field which is interacting with a coil of wire, and that coil of wire is connected to a battery. Okay, so the point about a motor is that it takes in electrical energy from the battery and turns it into kinetic energy. So in other words, what we're doing, we're taking chemical energy from the battery, turning that into electrical energy, which then flows through the wires in the motor and turns into kinetic energy. And we can see that because the motor will rotate as a result. And the reason it rotates is due to the force on those current carrying wires in the magnetic field. Now, the really tricky bit for motors is the additional bit which you can see written on the screen, which is the split ring commutator. It's a bit of a mouthful to say, and it's not really sort of clear what this is. Now, the nice thing is at GCSE, you don't really have to have a really, really detailed understanding of this. Okay, but what you must understand is that it is crucial to the operation of the motor. If we didn't have the commutator, then what would happen is the wires would simply get very tangled, but also actually our wires would experience opposite forces as it rotates, and so it would end up kind of flip-flopping backwards and forwards and not rotating around in a nice clear way. The split ring commutator steps in to stop that. Okay, this is our component here. You can see it's literally a ring of metal which is split up. There's a little hole in each side, and it's connected by a tiny carbon brush, and we'll talk about that in a second. What the commutator does is it reverses the current every half turn. And when we're talking about the current, we're talking about the current in the coil. What effectively happens is that our commutator rotates, it breaks the circuit, and then when the circuit's reconnected, the current's in the opposite direction, and that allows that rotation to carry on. It's connected to the brushes, but the brushes stay still. So the brushes and the commutator form the electrical connection so that the electricity can get into the motor. And for half of the time, the red half, for example, is in contact with one brush, and on the other half of the time, it's in contact with a brush which is opposite. And so therefore, for half a turn, each side of the commutator is in contact with one of the brushes, and then that changes during the second half of the turn. So we can say that each half of the commutator is in contact with the carbon brushes alternately. Okay, so that's the basics of a motor. We put electrical energy in, we get kinetic out, and we've got this extra detail which is the commutator. And I know that students don't like this one because it's one of those things you have to learn about, but we don't really get a chance to understand fully, okay, at this stage. Really, we're just knowing the idea that this commutator is essential to the working of the motor. Let's compare the structure of the motor to the generator. Okay, and you can see it's actually quite similar. You've got a magnet there, okay, and we've got some wires. The difference with the generator is that it actually takes mechanical energy or kinetic energy and converts that into electrical energy. What happens in a generator is we might spin the coil, and as a result, we're wanting that electricity to pass through a circuit and be available for use in some other way. Okay, you may have seen these in kind of handheld torches, something like that. They are using small generators to power. So, what do we need to know about these? Well, as we turn the alternator, okay, that's the bit that you hold on to, the coil will rotate in the magnetic field, and that causes an AC, alternating EMF, in my coil. And that AC voltage has got a wave-like shape. You can see it on the right-hand side. and that's carried away by the carbon brushes to something else, for example, a light or a speaker or anything like that. Now again, you'll notice that there's a similar kind of thing in the generator, which looks maybe a little bit like a split ring commutator. It's not. These are what we call slip rings. And slip rings are required in order to pass the electricity from the generator to an external circuit. If we didn't have the slip rings, then we wouldn't have any kind of path for the electricity to travel down. Now, we have another set of brushes here. These are carbon brushes, and they connect the whole thing up. And you notice there the difference with our commutator is that each slip ring is connected to one, I should say one, not on, my apologies, particular carbon brush. Okay, and so during that rotation, what happens is the coil will turn around. It will maintain the connection with the slip ring. The slip rings are connected to the carbon brushes, and those carbon brushes pass the electricity onto the external circuit, where it is found as an AC voltage. Okay, so again, you don't need to know a lot about the construction of these things. You need to know these basic ideas. Okay, so what I thought I'd do is sort of summarize a few of them for you. Similarities and differences. Well, a similarity, you'll not likely be asked about this in the exam, but I thought it was worth pointing out. Both of them involve a metal wire, or ideally a metal coil, moving in a magnetic field. Okay, and I could be even more specific there. I could say it's a metal coil rotating in a magnetic field. We'd usually use copper for that. You're more likely to be asked about the differences. So let's have a look at those. One, okay, motors take electrical energy in and convert it to kinetic, whereas generators do the opposite. So if you're looking at a question about energy conversions, you might want to think about that. Another difference. Motors take in direct current. You noticed in our picture of the motor, we had a battery with direct current, whereas generators, they will produce alternating current. So not only are they different in terms of energy conversions, they're different in terms of the types of electricity we are involved in. In one case, we're putting in some direct current, and the other, we're getting out some alternating current. Difference, key one, where a motor has a split ring commutator, generator has a set of slip rings. Okay, a set of slip rings, and those are crucial to the operation, as we have explained in the previous slides. Now, what we'll talk about later is the idea of generating electricity. Hopefully you can see that generator is the key idea behind our generation in something like a wind turbine, for example. It's exactly the same principle. It's simply the rotation of our coil inside a magnetic field, and that's something that we'll be looking at further in later lessons. As ever, if you've got any questions, please do let me know.